move on to electric current, it is a flow of charges. As you know, electric current is flow of charges. So let me just have an element like this. Okay. And I'm connecting it to a battery like this. And maybe I'll have some electrons, negative sign, negative sign, negative sign, negative sign. As you know, here you are having positive charge, so the electrons will be attracted to this direction. All these things you know. And this is a negative. So what will be the direction of current? Current will be in this direction. This is the direction of current. As you can see, electrons are flowing towards the left, whereas by our convention, current is going in the opposite direction. Or this convention was put forward by Benjamin Franklin. Benjamin Franklin was a very intelligent scientist who came forward with the concept of current, and you know how he did some experiments with lightning, etc. So this is a convention that was put forward by Benjamin Franklin, and it is universally accepted that if electrons move to one direction, our conventional current will be flowing in the opposite direction. And what is the unit of current? Unit of current, as you all know, is ampere. It is named after the scientist Ampere. So I write this as small I. Now I, current I is defined as, this is called as a definition. It is defined as dq by dt, where you can say current is defined as a rate of change of charge. Okay. And so 1 ampere will be equal to 1 coulomb per second. Reversely, Q, the total charge accumulated or the total charge transferred, is defined as integral T0 to T I dt, where Q is the charge transferred between time t0 and t. Okay. Now, let me come back to some other portion. This. Okay. Now, I am coming back to this equation. This equation. Now, if I look closely to that equation, I see that current is a variable quantity. Current is a time varying quantity. Why do I say that? Because it is respect to d by dt. It is a time varying quantity, which means that we can say that there can be several kinds or several types of current. So if the current does not change with respect to time, what do you call that? You call it as a steady current or direct current, DC. And if I draw a graph between time and I, and I represent it by capital I, always remember direct current is represented by capital letter I. And my current will be always in this direction, same. And now I know that because I know this equation is correct, the second case will be the current can change with respect to time in several ways. A time varying current can be represented by small I, time varying current, and a common form of time varying current. There can be different kinds. But for now, let's think about, let's limit our imagination to that common kind only. A common type of time varying current is sinusoidal in nature, sine wave, sinusoidal in nature, and this is called as AC. or alternating current, which we represent as AC. This is DC. And if I draw a graph between T and small I, I'll get a sine wave. It's varying like this. Okay. Now, where do I have DC? Where do I have AC? All the appliances in our household application, like washing machine, or maybe within the machine some other changes going, but what we give AC to our lighting systems, our electrical washing machine, refrigerator, AC, air conditioner, etc., etc. And maybe in our computer, we charge our computer by AC, etc. But within the computer, there are some SMPS, or there is a conversion of AC into DC. Our battery is a source for AC, and generators that they come up. All these things you'll learn later. Okay. For now, let's start with a small problem, simple problem. All of you should write this down. Okay. Okay. So the total charge entering a terminal, is given by Q is equal to phi t sine 4 pi t millicoulomb. Calculate the current at time equal to 0.5 seconds. Calculate the current at time is equal to time t equals 0.5 seconds. So you are given the value of Q, you are given the value of I. You know that this is the equation governing that I is equal to dq by dt. So let me find out I. I is equal to d by dt of Q, which is phi t sine 4 pi t. Phi sine 4 pi t plus, you are going to integrate the other, you are going to differentiate the other quantity. So you will get 20 pi t cos 4 pi. So I took this as one quantity, this as the other quantity. Okay. So much milliampere. You get phi sine 2 pi plus 10 pi cos 2 pi, which will be 10 pi as you said, which will be 31.42 milliampere. Now, what is this I? What kind of I is this? Is it the RMS value? Is it the peak value? Or is it some other value of I? What is this I? This is known as instantaneous value. Why do I say it's an instantaneous value? Because it is in terms of t. As I told you, this value, this current, this value of current I, this is the expression. This expression contains t, which means at every point it is a time varying quantity. The expression for I, all of you should listen. These are just basic things, but this makes it more interesting. Whenever you look at a problem, don't just look at all these values as mathematical equations. Look into it as some quantity, okay? Then you will have some more interest in it. So if this the expression, this expression for I is equal to phi sine something into t plus 20 something into t, etc., which means that it is a function of t, or I is going on varying with respect to time. And this is a sinusoidal function because you have sine or cos, whatever. So it is an addition of a sinusoidal function with a cosine function, or it is an AC. If you can say that it is an alternating current in one sense. Now, what is the value at 0.5 seconds? You put that value of t in that and you get a constant value. At t is equal to 0.5 seconds, this is the correct value. Okay, that is all. Then one more question. Oh, I wanted to teach you more. Okay, one more question. Take down. Yeah. Determine, second question, determine the total charge entering a terminal. Determine the total charge entering a terminal between t is equal to 1 second and t is equal to 2 seconds if the current passing through the terminal, if the current passing through the terminal is I is equal to 3t squared minus t amperes. You are asked to find out the value of Q. And Q you know is integral of T0 to T I dt or T1 to T2 okay, I dt, which is equal to integral of 3t squared minus t, 3t squared minus t between the limits 1 and 2 dt. And you will end up, you do this and you will get t cubed minus t squared by 2 within the limits 1 and 2, and on substitution you will get it as 5.5 coulomb. This is very easy. The only thing is you have to remember these equations. Okay. Then I am giving you a homework problem. Just take down this homework problem and that's all for today. The current flowing through an element is, I is equal to 2 amperes when t lies between the time 0 and 1 second. And it is equal to 2t squared amperes. You needn't even write the ampere there. Okay, 2t squared when t is greater than 1. Calculate the charge. Calculate the charge entering the element between time t is equal to 0 and or 2 t is equal to 2 seconds. This is the homework problem. Check whether you are getting this answer. 6.667.